Hey everyone, this is Yahya Bunaga. I'm a graduating senior at AUC, and currently I'm working on my last internship as a bachelor student at AUC. Currently I'm in Germany working in a company called Me Notes, and that's me over there. And I'd love to give you a little bit of introduction to the company. I work for a company called Minodes GmbH, or as they say in Germany, or in German, Minodes GmbH. And this is a startup that provides analytics tool for stores. So they are like they are known as the Google Analytics for store. So they help stores know how many visitors they have, and if visitors like come back, and all of this is using the wireless technology. So they deploy like these nodes that they bought in the store, and these nodes could track your phone so long as you have your wireless open. So the company is located in Berlin, in Germany, and they have offices in London, in the UK, and in New York City, in the States. And they operate in Europe, the United States, Canada, and Southeast Asia, specifically in India. And they also have some famous brands and customers like Kaufland, which is the biggest German retailer store, and some other famous like international brands like Marks and Spencer, like Valora, like Euskada and McKinsey and Co., the consulting company. They currently employ around 55 employees in Berlin, and that I'm not sure about other locations, but I know in our office in Berlin we have around like 55 employees as of now. So I'd like to give you a bit of introduction also about my supervisor. He's called like Fabian Brusig, and he's the CTO of the company. He holds a bachelor and a master's and a PhD in computer science from Karlsruhe Institute of Technology in Germany. And his PhD work was in the field of distributed systems and software performance models, where his main job was to analyze performance and optimize software to make it faster and run in parallel environments. And I'd love to give you more of information about what I did in the company. So I've done two internships, one last summer and one that I'm continuing right now, which is to some extent the continuation of what I did in the last summer. I worked mainly in two projects, or mainly in two domains. The first one, software engineering. The other one is data science. In software engineering, I rewrote a Ruby backend to scale out. So we have this system where all of our nodes from all of our stores slash customers around the world, they send requests, and we have around 5,000 of them. And in order to scale out while the company is growing, we need a system that would not write all of this information to our database, which is a PostgreSQL instance, or like a cluster of instances. And my job was to implement a caching layer using Redis and to rewrite their backend so that it implements a queuing system that would cluster the request, and then instead of writing, let's say, 1,000 requests, we're going to cluster all of these and batch them in one query slash request that would insert like the 1,000 elements at one chunk. And that proves to be much faster, especially that we do that on the backend. So whenever an update comes to our system, we don't really contact the database, we save it in our memory using Redis, and then we dispatch it later to the database system. The other project was data science project, where I worked on matching our visitors slash customers with the receipts. So now that we have a node in a store, we could know who of the people, or like how many customers, and we know like the MAC addresses of the phones. And then now I wanna know, okay, which one of those customers ordered this one receipt. So given that this is a time series data problem, because we have each phone pings at a certain time, and each receipt is being issued, or like is being paid for at a certain time, then a phone that pinged a phone that has the strongest signal, or in other words, that like closest to our node, that's is going to be in besides the POS system, the point of sale system, is the more likely the person who bought this who bought like this receipt or this product. And my job was to analyze this data, the phone pings or the phone requests and the receipts, and try to match them, come up with a machine learning clustering algorithm so that I have buckets which are my receipts, and I need to fill those buckets with the buyers, or with the phones, the people that bought these receipts, or like they paid for these receipts. That was quite challenging actually, and it needs a lot of data labeling and making sure that the system actually generalizes well, and it does not just perform well in a subset of the bigger problem. And what I'm working on now in the spring 2017 was another data science project where I needed to classify the input of this status monitoring system that I worked on last summer, and making sure that, okay, now we have a system that scales and tells us, okay, how performant our nodes all over all of our customers' stores. Now we want to make sure and check how could we use our historical data and apply some machine learning algorithm to it in order to predict the future. So what kind of symptoms to all of our features that would cause a failure in the system, for example, and then we would love to take precautious, like our precaution as, like our precaution actions like toward this, like future failures. And I use the support vector machine with a radial basis function on our features and the available features to do this job. And actually, surprisingly, it actually performed pretty well. It achieved around 97% on only two features, which are how many pings we have on average and how long like the ping lasts. And this is like, as you see, this is the shape of the radial basis function. But if you want to know more about the system, you could contact me. I have my email in the last slide. And my last project was a software engineering project where I needed to optimize a script for data aggregation that queries our data set. So in order to have an idea of the magnitude of the problem, we have around 3 to 400 million records, so data set item. And now if you want to extract some information from there, that's going to be a pain. That's why we need to aggregate. And in order to aggregate, we don't like our current status would probably aggregation would take around maybe 10 hours. And I developed a script that would crunch around 1 million records per minute, and that would take, as of now, around half an hour, 20 minutes to 30 minutes to process all of our data, which is already at 23.1-ish speed up using multiprocessing in Python. So we use the standard multiprocessing library in Python, and you could really see that the numbers are pretty impressive, because when you use only one core, you have around 10 seconds to do the same thing that takes like only 40, or like that takes only like almost half a second, or like 400 milliseconds on a 24 core machine. So yeah, that's what I worked on now. And like right now I'm working on my last project. It's not done yet, but if you have any questions, you could also ask me more about it. I always respond to emails. So it's like if you have any question about the company, about any system that you're interested in, you could always contact me. And thank you so much. I'd love to thank Dr. Awad Khalil as well for letting me do what I'm doing right now. Thank you all, and have a great day.